CIS27. In this video, I'm going to go over Unit 7, and in this week, we are going to cover Chapter 7, in which we'll talk about attacks, escalation of privileges and techniques, different types of attacks such as man-in-the-middle, poisoning, DNS, and brute force. And the task that we need to complete is Chapter 7. We're going to read Chapter 7. We're going to complete Unit 7 in class assignment, and we are going to complete Lab 7, and we're going to attempt our extra credit, which help you prepare for the Quiz 3, and we are going to take Quiz 3, which covers Chapter 4 and 5. So to start, we can download our notes for Chapter 7. You will find it on the page after the task page. Then we will also need to download Unit 7 in class assignment, and you can use this to follow along with the notes when you watch this video. So to start, we're going to talk about denial of service attack versus distributed denial of service attack. So in a DOS or denial of service attack, we would have one attacker against one target. It's 1-to-1. In the distributed denial of service attack, there will be 2 or more computers against a single target. Last week we talked about how attacker can use bots, or they can utilize zombie, actually, which is computer system that they can take over by using social engineering, and they would use those zombies to be able to attack a single target. The goal in distributed denial of service attack or denial of service attack is to make the system unavailable to the legitimate users. And those systems could be web servers, email servers, any of the centralized system that you often see in organization. So denial of service simply would disable the availability as part of the security goal. And in many forms of attack, the attacker would start with escalation of privileges. So after they gather the information, they want to gain access to the system. And once they gain access to the system, they want to be an administrator or the root user account. And they would use different techniques to gain those privileges. So one technique would be to social engineer the legitimate user to give them the credential by embedding a link in an email and sending it to a group of users that would have administrator privilege. Another technique that is often used in attack would be spoofing. And spoofing is impersonating or masquerading a system or an account. You often hear the 2 forms of spoofing, which is MAC address spoofing and IP spoofing. So MAC address spoofing is the use of software methods that overwhelms the switch to cause MAC address flood. And this is a way that they can bypass the MAC address filter on the network. So those type of filter can be implemented in firewall, in prevention systems, or even routers. IP spoofing is when they change the source address so it looks like the packet is originated from a different source, so it can't track back to their system. And they would launch attack from a single system, and it would appear as it would be from a different computer or a different system, or using different address. Now, another type of attack that often is used relating to TCP/IP would be Syn Flood Attack. And this is used against servers on the internet. it will be easy to launch because internet is readily available through connection through the ISP, and it could be difficult to stop. Now, this type of attack capitalizes on TCP process, which it would cause the disruption in the handshake, which includes three-way handshake. Two systems normally establish a session by sending 3 packets. The client would send a synchronized packet to the server. The server would then respond by sending a Syn Act or synchronization acknowledgement packet. Then the client would complete the handshake by acknowledging sending the ACK packet after the session is established and to exchange the data with the server. Now, in this type of attack, the attacker never completes the handshake by sending the ACK. They would send a barrage of the Syn packets, so leaving the server with multiple half-open connections, and it would consume resources on the server as it's always going to wait and for that connection to establish. So with the Linux, you would see that IP tables command can be the threshold for the Syn packets, blocking them after the threshold is set, and it denies the service for all clients. And in the last lab, you saw a little bit of details on how you would use different tools in order to look at different type of attacks on Kali Linux. So now let's go back to our assignment. In our assignment, the first question asks you, what is the primary difference between DOS and DDoS? DOS, we have one attacker against one target. Distributed denial of service, DDoS, is where the attacker from 2 or more computers against a single target. So distributed means that it would be from multiple sources against one target. For question 2, it asks you for the 2 main types of spoofing. We have MAC address spoofing and we have IP spoofing. And there will be more different types of spoofing. However, in this chapter, we cover 2 main types. The MAC address spoofing uses software methods to overwhelm the switch, and it causes MAC flooding that would allow the attacker to bypass the MAC address filter. IP spoofing, in this attack, the attacker would change the source address to make it look like it's originated from a different source. Then the attacker would launch from a single system which appears to have a different IP address, so it's difficult to track. And to prevent Syn Attack, as we talked about Syn Attack attacks with the 3-way handshake, how it disrupts the handshake process. So to prevent or reduce the possibility of this type of attack, we would monitor the network traffic. You can use network monitoring tool like Microsoft provides network monitor tool that comes with the server, or you can use Wireshark, which is a network sniffer. You can analyze the network traffic but against the baseline. You can set firewall rules to block or prevent Syn Flood. So you simply just create a new rule to prevent Syn Floods. You can implement VPN for external connections. So virtual private network would establish a connection specifically based on your settings. We can restrict user access to least privilege. That means that the user should only be allowed to access the system based on their need to perform. We should manage data classification and access on the network and the system. So data classification pertains to different categories, and we need to take a look at data at rest and data in motion. Data at rest are the data that's being stored on the system, and data in motion is data that's being sent in and receiving into the network. So the category of the data classification could be public, private, highly secretive, etc. And we would control the permissions of the data access based on that. We can also implement data encryption for highly sensitive data or highly secretive data. We should also perform data backup in the case we have data corruption or data loss. So these are the things that we can do to prevent and reduce the possibility of the Syn attack. Data backup is really for in the case where we lose data. But as far as the emphasis, the first three that's highlighted is really the prevention part and the reduction of the Syn attack. So going back to the notes, it talks about Syn attack on page 1. Going into page 2, we'll touch on man-in-the-middle attacks. And man-in-the-middle attacks is where the attacker would listen in to the traffic to start, and they would try to intercept the packets or network traffic, and they would use separate system that accepts traffic from each of the parties, so from the source and the destination, and they would forward the traffic to another system. And in the process of doing that, it will interrupt the traffic. They can use packet crafting tools to insert different information like the source and the destination. There would be malicious code sometime would be involved in the insertion. Now, to protect for Windows environment, we can use Kerberos. And because Kerberos require mutual authentication, so it does not allow the system to receive malicious script or code in the middle of the conversation without the knowledge of the system. So Kerberos would help reduce the man-in-the-middle attack. So going back to the question for number 4, what is used to prevent man-in-the-middle attack? We mentioned that we can use Kerberos in Windows system because it allows mutual authentication and it does not allow malicious system to insert itself in the middle of conversation without the knowledge of the system. We can also use encryption for authenticated sessions that require key pairs, such as RSA. So RSA sometimes would be required if you use technology that would be outside of Windows system. You don't have Kerberos for Windows, then you can implement key pair or PKI such as RSA. Now, the next form of attack is ARP poisoning. And ARP poisoning misleads the computer or the switches with the MAC address because ARP, its job ARP stands for Address Resolution Protocol, and it resolves MAC address to IP. So for the resolution for the IP address of the system to the MAC address and store the result in the area of the cache. And in the poisoning, it would cause the switches to look at the actual MAC address system because it would change the memory cache information of the address. So TCP/IP uses address to get packet to the destination network. So it would for the routing portion, we would rely on the IP. And once the packet gets into the network, the MAC address would be where we would pinpoint the system in that part of the network. So then we would require ARP. Now, so once the packet arrives to the network destination, it uses the MAC address to find the correct system. And so in that, we would see ARP request. And this is broadcast. That means it's sent to everyone, and it would say, who has this IP? And the system that has that IP, the computer, would then respond to that with the MAC address. It would say me, and I'm at this address. Now the computer that sent the ARP request caches the MAC address for the IP, so that way it would store that information. All operating system would hear ARP reply, whether you have Mac OS, Windows, Linux, and it would cache this MAC address, which is to the physical network interface card. Now, the vulnerability behind it is it's very trusting. It believes every reply packet to be legitimate, so it cannot distinguish on its own. So the attacker can create ARP reply packets that would have bogus address, and that would be stored into the cache, would cause it to have to be what we call ARP poisoning. So the type of attacks that usually is performed with or for ARP poisoning would be man in the middle, so that way they can listen in and intercept the traffic. And with ARP poisoning, that will cause disruption or corruption to that particular system, so that will be denial of service. And man in the middle, with ARP poisoning, the attacker redirect the network traffic with malicious code, and the traffic is redirected to the attacker from the router. When the victim sends all the traffic to the destination for the router, that will be routed to the attacker, and the attacker would capture the data using IP forwarding and send the traffic to the router so that the victim is unaware of the attack. ARP DOS is when the attacker send ARP reply with bogus MAC address to the default gateway, which is also a router. And all computers cache the bogus address, and they cannot reach it to stop all traffic by the network. So you would see that there would be man in the middle and DOS being involved with ARP poisoning. So for the next question, it asks you what types of attacks can derive from ARP poisoning attack, and that would be man in the middle and denial of service for number 5. Then next we're going to talk about DNS. And DNS attacks can also be DNS poisoning, farming, or distributed denial of service. So DNS stands for Domain Name System. This allows us to resolve host name to IP addresses, and it also provides forward and reverse lookup, so we can look up name to IP and IP to name. And when we do IP to name lookup, that is called reverse lookup. And in your past lab, you have touched on DNS and for your security DNS and how to protect your records. So the attacker would spoof the computer identity by using different name during the session. And the TCP IP packets would include the IP address of the masquerading system, and reverse lookup shows the system's actual name. If the name is different, that would cause suspicion. So because the records on the DNS identifies the name to the IP or IP to the name. In the reverse lookup, it will identify the IP to the name. So the attacker against the DNS service, they can use a false name or an actual name of a system that would be masquerading their own, so that causes the poisoning to the record. So now they can also modify the record, which would actually be the poisoning part of the DNS, or they can spoof to be identified as a system that's part of that domain. So in the DNS attack, we would see DNS poisoning, farming, and DDoS. So on page 2, it talks about poisoning is when they modify or corrupt DNS result, modify IP address associated with the domain like we touched on. DNS server can use domain name system security extension to protect this record, and we did a lab on that earlier on. So you can use DNSSEC to protect the records and prevent DNS poisoning attack. Another form of attack that relates to DNS would be farming, in which they manipulate the DNS name resolution process. It corrupts the DNS server or the client and redirect the user to a different domain. So the file on Windows system would be located in C Windows System 32 driver etc folder. And that file contains IP addresses with host name mappings and comments on the Windows systems, such as, for example, this is the IP address and this is the name of the system. This is an IP address and this is the domain of the system. So the attacker can manipulate or take advantage of the vulnerability of the system by using the DNS records in their attack. Distributed denial of service DNS attack would infect IoT or internet connected device using malware such as Mirai, which forces the system to become bots on botnets, and sometimes they can take over system to be zombie, so they would use script or software tools in order to do that. And using those systems now, they can send queries to the DNS server from the infected system and prevent other users, legitimate users, from accessing the website or the domain. So it makes that domain become unavailable or disrupted to legitimate users. So in such sense, that will be distributed denial of service attack using DNS. Amplification attacks is also a type of distributed denial of service, and it uses method that increases the traffic. It would amplify the traffic that is sent or the request from the victim. An example of this is a Smurf attack, and Smurf attack spoofs the stored address and redirect broadcast ping packet to flood the target. So a Smurf attack is a ping attack, but it actually also spoof where they're pinging from. As ping is unicast, it's going to be computer to computer. It would send ICMP echo requests from one system to the other. Once the other system receives it, it would send the echo reply or response. In a Smurf attack, the attacker would send ping out as a broadcast. It would send it to all the computers on that subnetwork or that network segment. And if in the case they spoof the source IP, they would substitute the source IP with the victim's IP address to cause the flood for the ICMP reply. Because it's two-way, where you would have the echo request that needs to be responded. So if they substitute the source IP with the victim's IP, that will cause the flood of the ICMP replies. And in the amplification attack, that can be done also on DNS server. So on a DNS server, the DNS sends to other DNS servers, and if the IP is spoofed with the address, the DNS would then have to send it to the zone using the zone record, and the amplification of data being sent from the victim will overload the victim system. So the same type of attack can perform on DNS or any type of servers. Network time protocol, your Ntp Amplification Attack uses monolith command, and because it normally would use a list to be able to identify the host that's connected to that server. So to take advantage of this, the attacker would spoof the source IP, send the command, and floods the victim with the details of 600 or more system that needs to be requested for time from the server. And the server job is to provide time information. So if the attacker spoofed the source IP and ask by sending the command, that can cause a flood, because now the server has to respond to 600 or many type of systems. Okay. So in the question, it asks you what type of attacks are launched against DNS services. For number 6, we can put down DNS poisoning, farming, distributed denial of service against DNS. For question 7, it asks you what is used on DNS server to prevent DNS poisoning. We would have to use domain name system security extensions or DNSSEC to protect the record and prevent DNS poison attack. In Windows OS, where is the host file located? You can find the host files in C drive under the folder Windows, System32, Drivers, etc. And you will be able to locate the host file through that path. For question 9, it asks you what is used in the Ntp Amplification Attack. The attack uses monolith command, which sends a list to 600 hosts that's connected to the Ntp server. The attacker spoofs the source IP when sending command and floods the victim with the details of 600 systems that is requested the time of the Ntp server. Now going back to our notes, next we're going to talk about password attacks. And password attack include brute force attack, dictionary attack, and rainbow attack. So password attack simply is a form of attack to discover or bypass password being used for that system or certain devices on the network. Sometimes that could be cryptographic attack, or other times it could be brute force attack. Tried and true, meaning that they would try for as many different passwords as possible. So in the brute force attack, it's going to try to guess all possible character combinations to the password. There are two types of brute force. One is online, the other is offline. So in the online, the attacker would attempt to identify the password by repeatedly guessing the username and the password for connected system that would be online. A tool that they would use would be Ncrack or Kane Enable, and we can reduce the attempt or buy some time by using account lockout setting. So in account lockout setting, that will be part of the security policy settings, then you can change this to where after 5 attempts or a certain number of attempts, the user for that particular user account, then it would lock them out for a certain amount of time, like 30 minutes to an hour. This just slows them down. It doesn't deter or deter the attack. So in that time, what we can do is we can look at logs. We can look at how we can better protect that particular user account. If, so account lockout only buys us some time. Now in the second bullet here, it talks about secure shell can disconnect the attacker if he hasn't logged in within 60 seconds. And that would limit the number of authentication attempts per connection. So using secure shell for connection would put some restriction on the attacker. And again, all we're doing is we are just buying a little bit of time there. Okay. Offline password attack is when the attacker attempts to discover the password from the captured database or packet scan. That would be not to a connected system. So now in some case, if we use encryption or if we use hash format for our password storage, that would again protect our password but buy us some time. We're not completely foolproof in such case, but we do have a reduce of the risk if we store our password is encrypted or using hash, and also account lockout will buy us some time. Okay. Using complex password just also give us time, because the time that it takes for them to crack that password would be a lot longer if the password is complex and more than 8 characters. So this is why you should always create user account and educate the user to use complex and lengthy passphrase. Okay, anything above 8 characters would buy you longer time, especially with brute force. With the dictionary attack, the attacker would simply use common words or known dictionary words, and the dictionary can include names, places, and it can use different languages. So now they would create or find a dictionary list via the internet, and they would import that into the tool that they use. For example, Cane Enable, it allows you to use the default template, or you can create your own dictionary to be able to import that in and use that dictionary to check against password, because many people use common known dictionary words. So this is why users should have complex password that is non-dictionary word in any language. Password hashes. So password hashes is not foolproof either, in that hash attacks can occur. They would use tools to discover the hash, and tools like MD5 online tools that will be able to allows the user to enter, provide password in a text format, and it will give you a hash. So certain hashes are vulnerable, and so passwords are rarely sent across the networks as clear text. They are often sent with hash or stored with hash or encryption keys. So if the hash is passed across the network as unencrypted format, they can sniff that out by looking at the packet, and they can use that to log on to the system. And often you would see this being done for wireless passphrase, especially in in a network environment. They can try to monitor or look at your network traffic and be able to try to find ways to guess your passphrase to wireless. Pass the hash attack is when they discover the hash from the user password and use it to log into the system as the user. So they would impersonate that user. And in the older security protocols, such as the Microsoft LAN Manager, LM, or NTLM, they are susceptible to pass the hash attack. So later on, they created a newer version called NTLM version 2. This should be used to configure the system so that way it would refuse the attack. So LM and NTLM is no longer good. Okay. So for the next question, we would go to answer number 10. What are two types of brute force attack? Online and offline. Online is used to discover password on a connected system. It says online system. It doesn't necessarily mean that it's on the internet, but it's connected system. And they would try to log on to an account by repeatedly guess the username and password. So we can implement account lockout and secure shell connection. Offline password attack is when they attempt to discover the password by looking at the captured database or a captured packet scan. And to really combat that, we should use complex password, and we would use hash and encryption when we store the password. For question 11, What methods are used to reduce the risk of online and offline brute force attacks? We should use account lockout policy, where we would control allowable attempts for the user to log in incorrectly. So if they log in, they fail to log in 5 times, it will lock them out. Account lockout duration policy, this should be used with the first option. We would implement the period of time before the user can re-log in. So as they get locked out, we would implement the account lockout duration, which is 30 minutes, an hour, 24 hours. So that way it will buy us time to investigate that account. Next, we can use complex password policy. This allows us to control how the user create their password, and we would enforce complex password for user account. We would also use password history policy, that in this they cannot reuse the password that historically was stored. So we can set it for the last 5 passwords they cannot use. So password history does that. And 2 other things outside of the policy, we want to make sure we have user awareness and training, and we want to store password with encryption. So those are the things that need to be implemented to protect passwords. For number 12, it asks you what older protocols are susceptible to pass the hash attack. That will be your Microsoft LAN Manager LM and NTLM. These are the legacy older protocol. NTLM version 2 was later implemented, and that is insusceptible to pass the hash attack, as it would use different hashes. This concludes my part 1 video. Please watch part 2 video for the second part of the lecture, in which I will continue with different type of attacks following the password brute force attack.